Can people see and hear me?
Yeah, I can see your screen.
And does it look right?
Perfect, Adrian.
Good. Okay. Well, we'll skip over this bit here. And as I said, our work was to send encryption keys at the quantum level. And our first effort was to do it over a short distance of 5 kilometres from the communications tower in Telstra to the University of Canberra. And here I am at the University of Canberra looking through a telescope at the tower. And this little bright spot here is one of our lasers. I hope that's clear enough for people. Whoa. Here, this is a broad idea of what we're after, and the ability to send the encryption key and data to a satellite, a low Earth orbiting satellite, and then it could be moved to a different location. So let's get on with it. I'm not sure if this is very clear, but this is part of our transmitting system. We have a couple of lasers, a red laser, an infrared laser, and our desire was to create very short pulses, very short indeed. And both of the lasers were mounted on a very old theodolite that we'd put a new platform onto. And then one of our things was to collimate these lasers so they were exactly in line also with the theodolite optical system. One of the key parts was this a clock generator at 10 megahertz, which was need to synchronize both the transmitter and the receiving end. To control all of this, and this is where Forth comes into it, we had this PC, connected a parallel port to it, and then we could use that to turn the lasers on and off and change the various functions. We'll come to that in a second. So, and this is an example of what the receiving end looked like. This is back at the university in the evening one time. The professor there operating. We had a telescope. There were optical splitters, infrared filters, a fiber, actually a plastic fiber, and also a camera, just an ordinary video camera. And that helped with us with the pointing. And you can see in this TV, this image here, we're looking at the tower, and that's our red laser coming through. Getting the infrared to land exactly on the end of the fiber was a very difficult task, a lot of fine adjustments. Anyway, this also then fed into the receiving part, which consisted of detectors, and we wanted to be able to receive at the single photon level. So we had an avalanche diode photo detector, and that fed into the signals from there into an amplifier, this thing called a rate meter, which is just an integrator, and they also from there into a coincidence detector. And this coincidence detector was gated by the same clock signals, and that was important because our pulses were very short, and timing of those was super important. So as I said, back in the transmitter, we had a bit of Forth code, and this is just the beginning of it. It's nothing really special, I guess. It was G-Forth from whatever vintage it was, set up a couple of constants to do various things, and then a short bit of code, this way. And then towards the end of the code, which is again super short, there was just a simple text-based menu to switch things on and off, which you can see in this portion, and then a simple case statement here to be able to do that. Beauty of Forth, takes no time to create, easy to modify, and was very clear for the operator. If I was not there or somebody else was there, they could easily do it. Start it, menu came up, execute the function. Anytime we needed to change something, maybe it took 1 or 2 minutes, and away we went again. This code and the computer sitted remotely on Telstra Tower, and we just had an SSH session into there, and it ran perfectly. Here you can see, looking out the window, you can see the tower in the distance and a little faint red light. So that's us. And there it is again. And amongst all these microwave dishes, our little box is just there with the theodolites in there. So, yeah. If I go here, next one, this is a short video clip. And here you can see with the red laser, the scintillation. This is the effect of the atmosphere. And we knew that would be a problem on the Earth part and also up into space. So there was some analysis done on that. And the other curious thing about in this little experiment is this is a big, tall communications tower. And we wondered why, it should be fixed in position, but it appeared to move, and we never figured out what it was. We thought, oh, something's wrong with our mounting on the tower or whatever it was. And then we learned from some other people that the sun, when it heats one side compared to another over the course of the day, the tower tilts from one direction to another as it heats up and warms from one place to another. Anyhow, we needed to increase our distance, and we were lucky enough. We had 2 smaller steps, and then we eventually went to the 30 kilometres. We found some cooperative farmers who had sheds, and this is our receiving system here. There's the telescope, and this is a retro reflector. I guess you know what these are. Like in the old surveying systems, they would look there and they'd have this little reflective, this prism there, a retro reflector. So the light would come in and come back out again. This is our transmitting system here. And this is the important part, I guess. This is the theodolite with the 2 lasers, a red laser and a better infrared laser. Again, we had use of a shed where we kept, at this time we upgraded to a rubidium clock because we needed very good stability. And we would turn this clock on for at least half an hour or more beforehand, and the cables came out, and then we had various things set up. We do this in the late afternoon and then operate at night time. And this is purely a selfie photograph showing at the end of the night, getting ready for our night's work, stuff that we'd trundle out each evening we needed to do our activities. Here you see a little bit more. And yep, sure, this has all worked. We did our successful work, and this just again demonstrates what the whole idea is. You'd send the key at the quantum level up to a satellite, store some data. The satellite would move to a new location, and then it would go down, reverse the process. So not very fast, obviously, and you wouldn't reliably send a lot of data, but the idea was secure, extremely secure. And well, yeah, it works. The Chinese, while the US and the Europeans were still playing with equipment over short distance, we had actually achieved the 30 kilometers, way ahead of them by months and months. And eventually the Chinese thought this would be useful, and they had planned to put up this demonstration satellite, which they eventually did. And it proved reasonably successful. I don't know how much of a commercial activity it's turned out to be. And like a lot of these things, a few papers were published about this and that. And this is the one that finally summarizes our activities and our success. And then some years later, it had been extended to 1,200 kilometers, the feasibility to do that. So I guess in summary, what I have to say is that Forth enabled us to do the initial experiments and control things in something that was quick and easy, and it all worked. Thank you.
I have a very basic question. You to make this work, you were talking about single photon, but it seems like there's an awful lot of photons there with a visible laser. How do you isolate a single photon? How does that actually work?
Yeah, okay, yeah, very fair indeed. Firstly, they were very short pulses of light, so there was we would make them as short as possible with high rise times. Then we would attenuate the laser to as low a level as possible, and then we would actually it went on the receiving side. We had the fiber optic cable, and we would squeeze the cable so it was very inefficient, and so only a few photons would leak through, and that way we knew that we could count there was a fixed number, and of course ones and zeros were represented by polarization. So we didn't want to do send an actual key. We wanted to demonstrate the feasibility of it, and this is the way that we could do so. That answer the question enough?
Yes, that makes sense.
Yeah, good.
So I had a question. What are you doing with the parallel port? What were you actually activating?
Yeah, it was the parallel enabled us to switch lasers on and off, the red or the red and the infrared, and to change them from continuous to pulsed operation. And there was another function we had in there as well. Yeah, nothing very sophisticated, but it was easy and very low budget.
Thank you.
No more questions?
Probably not at this time. So,
Okay.
if I'd like to mention, as there's been some chat, please send your slides, and Adrian and everybody else that's presented, please send your slides to Dave Jaffe, who will post them on the website. If you don't know Dave's address, you can send them to me and I'll forward them on to Dave. Don Golding, do we have Don? Okay, well, maybe we'll catch up with Don after the palindromes. Are we, Bill, are you available? Are you on deck?